Have you ever watched Are You Smarter Than a Fifth Grader?
No.
Yes.
If you have, ladies and gentlemen, what you realize is this. You are taught so many things that you just forget that, you know, the people, the questions they ask for Are You Smarter Than a Fifth Grader just come out of fifth grade books. You know, like do social studies or whatever. It's just that you don't ever remember them. I don't know where that's going, but I'm just saying. It's not like you're really smart in fifth grade. We're not really smart in eighth grade. All right, ready? Got it. First thing we're going to do is write down addition. This will be fast because all we're doing is defining some things here. Ready, get set, go. So all you're going to put down for this, in an addition problem, what are the parts of an addition problem? Let's say you have 6 plus 7 is 13. These two bad boys are called the, anybody? Good, addends. See, you don't know that anyways. Even though we talked about it in fifth grade, you are not smarter than a fifth grader. And then the answer to an addition problem is the sum. Very good. Done, ready, new piece of paper. I told you this was whirlwind. Subtraction problem. This one, you could win some big money if you're on the field, because people don't really ever remember this. 16 minus 9 is 7. Most people know that the answer to a subtraction problem is, yes, in fact, the difference. But most people don't know what those other two numbers are called, and they are called two different things. Okay. Addition, it doesn't matter because you can flip-flop add-ins and they don't change, but in subtraction, I can't change 16 and 9 to get the same answer. All right. So, anybody? 16 is the, nobody's looking in the book and following along. 16 is the min u end. Try that again. Min u end. The min u end. And 9 is the, oh, look at Kevin Wills is looking. What is it, Kev?
Subtrahend.
Yep, the subtrahend. Again, we probably did this in fifth grade. I probably labeled them in fifth grade, but we don't talk about very often, so you forgot. So
I kind of remember.
We did it because I still have no.
see, Kate says we did it. Are you smarter than a fifth grader? No. No. And then going to a multiplication problem. And nothing to know about this other than just 6 times 5 is 30. And again, because multiplication, the two things you multiply can be interchanged. They don't have to go in that order. We'll talk about that in a second. Those two things are called the factors. And the answer is called the product. Just so you have it in your notes. Everybody good with that? I don't want to go too slowly. And last but not least, we have not done division. Division's obscure, but not quite as bad as subtraction. 18 divided by 6 is 3. Most people know the answer to a division problem is called the quotient, but most people don't remember what these two things are called. The 6 is, Brady,
Dividend?
no, that's the divisor. Which makes sense because usually when we put OR next something, it does the dividing, so it's the divisor. The first one is the dividend. And maybe you can remember that because it's on the end. Dividend, divisor, I don't know. There's no good way to memorize it, it's just the way it is. Or you could remember that the one is in your car you have the visor, keeps the sun out. Now with that I do need you, let's put, I don't know, there's no good place to put it, so put it on under your division thing here, write this problem down. Because this is what the book will do to you. Right out of the book it says, what is the quotient? What is the quotient when, what is the quotient when the product of 3 and 6, when the product of 3 and 6 is, I'm see if it's going to be divided by something here, divided by the sum of 3 and 6. By the sum of 3 and 6. Big fat question mark there. Now, please don't tell me the answer, because it's not the answer that I'm so much care about. It's how you go about doing this. Do you have to write those words down? No. You don't have to recopy that problem on your paper, but I do need to see this. This is something where you kind of need to show some parentheses, and you just need to look at the keywords. If you look at the keywords here, we've got the word quotient, we've got the word product, we've got the divided, and we've got the sum. Those are kind of the keywords. First of all, what type of problem is this? Well, the first thing it says, what is the quotient? So you know this is a division problem. And what two things are getting divided? Okay, the product of this is getting divided by the sum of that. So really in math you should show it like this, because you have to do the product first. The product means multiplying. You multiply 3 times 6, and you're dividing it by a sum of 3 and 6. That is what I should see on your paper. You're dividing a product, this is the product, by a sum. And if you do it, 3 times 6 is 18. 18 divided by 9, 3 plus 6 is 9, gives you 2. And that would be your quotient of that. This part here, I should see. Everybody's happy? Yeah, it is Friday, you know. All right, are you ready? Because we're not done. Here comes the fun and exciting part here. Blank piece of paper. Give yourself lots of room because there will be lots on this one here, and this one is called properties. Properties. Did I spell it right? And I'm going to list them down for you, and then we're going to talk about each one of them. We have like 4 or 5 properties we're going to talk about today. The first one is the commutative property. And then we're going to talk about the associative property. And that's why you have notes, people. I don't expect you to remember this all right off the bat here. The associative property. And then we have what's called the identity property. And then last one we'll talk about is the, I think it's multiplication by 0. Look and see, just so I don't get you. Zero property, I guess it's called. Of multiplication. Chance to jot that down. We'll talk about each one. The commutative property, are you ready for me? The commutative property kind of comes from that word commute. Anybody know what the word commute means? Some of your parents commute to work, which means they go to work, they drive to work, they go from one place to another. When you think of the commutative property, think about moving or changing places. Your parents go to work, when they change place from their house to work. It means this. If you take 6 plus 5, that is the same thing as 5 plus 6. The numbers have flip-flop places, they have moved. okay? And 11 does equal 11, that's true. This is the commutative property of addition. And the commutative property also works for multiplication. 7 times 5 is the same thing as 5 times 7. That is multiplication. 35 equals 35. Please understand that there is no commutative property of subtraction because 8 minus 6 does not equal 6 minus 8. You can't do that. This is a positive 2, that's a negative 2. The commutative property only works with addition and multiplication. Again, it's important to know that the numbers have moved because what we talk about next, people get confused with all the time. And the book, when you get to the upper level mathematics, which you guys are starting to get to the cusp of, the brink of, the peak of, a lot of times they don't use numbers at all because I can put any number I want in there. So they will just write it out with letters and say this. A plus B equals B plus A. Because you can put any number you want in for those letters. This is kind of how the book will show that. Now the associative property, ladies and gentlemen, if you look at the root word of that, okay, you go to associate. If I asked you who you associate with, you could think about it, who's your little group that you kind of hang out with. Hopefully you associate with all sorts of people. But it looks like this. 5 plus 6 plus 7, parenthesis, I associate these two together, equals 5 plus 6 plus 7, but in this time I associate two different things together. And the question would be, does 5 plus 6, if you do this first and add 7 to it, you get 18. If you do this first, 6 plus 7 is 13, plus 5, you get 18. Does it work? Yes. This is the associative property of addition. And the key things to look for, ladies and gentlemen, have the numbers moved places? No. 5, 6, 7 in that order, 5, 6, 7 in that order. So it's not commutative property. The only thing that's changed is which ones you're associating together first. This one I put the parenthesis around the 5 and the 6 and did that first. This one I did the 6 and the 7 first. And again, the same thing works for multiplication. 2 times 5 times 10 is the same thing as 2 times 5 times 10, and it doesn't matter which ones I associate together first, I still get the same answer. Kate, will you close that door? In this case here, 10 times 10 is 100. In this case, 50 times 2 is 100. You get the same thing. Again, it works for addition, and it works for multiplication, but it will not work for subtraction. You should try it. 6 minus 2 minus 1. Does that equal 6 minus 2 minus 1? I don't know. Okay, be careful because sometimes it does work out. 6 minus 2 is 4 minus 1 is 3. 2 minus 1 is 1. 6 minus 1 is 5. It doesn't work for subtraction or division. Guess what? If I'm putting letters, what time does this class get over? Like this is just why 7th grade math is just the worst. It takes forever. What, if I were putting letters in for this, how would it look? A plus B plus C with the parenthesis around this would equal A plus B plus C with the parenthesis around that. Should have done it in blue just to make it consistent. Are you ready for some football?
No.
Yes. The identity property. Now, this one is kind of hard to figure out exactly what it means. But we have two different things that are not exactly the same. We have the identity of multiplication. and we have the identity of addition. And the identity property says, what do you do to something to end up getting the same thing? So if you think about it, you use these, you just never think about it. The identity property of multiplication. 6, what do I multiply 6 by to get 6? Charlie. 1. And that's what the identity property says. The identity property says that a number times 1 always gives you a number, the same number. But that's not the same for identity property of addition, because if I take 6, what do I add to 6 to get 6? 0. The identity property of addition is adding 0 to something gives you the same number. Again, if I were using letters to show that, it would be A times 1 equals A, and A plus 0 equals A. Not very exciting, but that's what it is. And I'm going to guess that you could probably tell me what the 0 property of multiplication is. Anybody want to take just an outside guess? Kate?
Anything times 0 is 0.
There you go. And that sums it up there. Anything times 0 is 0. Oh, look at it. Filled out the whole stinking board. That's kind of fun, isn't it? Yes. I'm exhausted, kids. Just literally figuratively exhausted. Now, here is what we're going to take a look at here, see. This is kind of how this comes to play, people. See if this makes sense to you, then by golly, it makes sense to you. 5 times 8 times 7. Write this down. This is under the same thing. Where 5 times 7 times 8. 5 times 7 times 8. Okay, let's say this was a problem, Lacey Robbins, that you were asked to do. Okay, now there's always little helpful, easier ways to do things in math, generally speaking. If you were doing that the easy way, what would be the easiest way to multiply that together? I mean, generally speaking, taking 8 times 7 and getting 56 and multiplying 56 times 5 is not, I mean, you can do it. I'm not saying you can't do it, but I'm saying there's an easier way to do it, because just like when you add numbers together, you look for groups of 10. When you multiply them together, you look for something that gives you easy stuff to work with. And Charlie would say,
5 times 7.
5 times, you think 35 and 8 is easy to multiply together? What is 35 times 8? All right, no, it's not easy if you have to write it down. I understand you can do it. Easier than that would be what, Sam? 5 times 8, because it gives you 40. And 40 times 7 is pretty simple, because 7 times 4 is 28. You put a 0, that's 280. 280 times it. But you can't just do that because you like to do that. You have to be able to prove why you can do that. Now, why does it work for me to multiply the 5 times the 8 first? Well, that is where these properties come in. Thanks for raising your hand, but I'll ask for your input in just a second here. How is it that I can multiply this 5 times the 8 first? How do I get there? This, by the way, is a little bit like when you get to high school geometry. You have to prove why you can do things. Well, in order for me to do this problem, I somehow got to get the 5 next to the 8. Which means I'm going to flip-flop these two numbers and change it to make it 5 times 8 times 7. Now, why can I do that? What property did I just use to do that? I moved two numbers, they flip-flopped. Daniel, I use the... Yeah, I can do that. Here's my proof because of the commutative property of multiplication. Now, I still can't do it because my parentheses around this 8 times the 7, I still have to do 8 times 7 first. But because of a property, Aiden, I can do what? Right, I can change the parentheses from that. what I'm associating it with, I'm gonna move the parenthesis and associate the 5 and the 8 together first. And that's because of what property?
Maybe.
No, that's the associative. Notice, again, who said commutative? Alright. Because look, 5, 8, and 7 are in the same order. They haven't moved. It's what you associated together. The parentheses move. When the parentheses move, it's associative. Okay? Yeah, we better make sure I write the rest of those letters up there. The most associative property is multiplication. And now I can do the problem. 5 times 8 is 40, and that's just the math. There's no property there. And then 40 times 7 is 280, which is still just the math. Okay, you don't have to prove that, that's just doing the problem. Okay, that's kind of why you need to understand, you can use those properties. Doesn't work with division or subtraction. Sometimes people clap after that, it's just so. That is enough of that. Let's stop this thing. You can see